Now that we've looked at density curves, let's look at a very specific one called the normal curve. The normal curve is going to be very, very useful to us, and so we're going to deal a lot with it. So first, let's generally talk about what it looks like. The first thing is that it's symmetric. It does look the same on both the right and the left sides. It is also single peaked, so it's not a bimodal symmetric. It does have a center peak. And it is bell-shaped. As a result, this is often also called the bell curve. And it's also completely described by mu and sigma, the mean and standard deviation. Given those two numbers, I can tell you a lot about this normal curve. So let's actually see what it looks like. Here's a picture of two different normal curves, so we can see that they are symmetric. They're the same on the right and the left, the dark blue and the light blue pieces. They have a single peak in the center. They are kind of shaped the same in this bell-shaped. And they're completely determined by mu and sigma. So mu, the mean, is always going to be right at the center of that peak. And sigma determines how tall and skinny it is or how wide and flat it is. Here's another picture that looks at normal distributions. This one shows you how that changing standard deviation sigma affects the shape. In general, the smaller values of sigma are tall and thin, whereas the bigger values of sigma make this a more wide and flat curve. And all of these have the same mean of 0. So now let's look at some examples using this curve. So the US female height has a mean of 65 inches and a standard deviation of 3.5 inches. And what I want to do is actually label this normal distribution curve. So the mean is always at the center. So the center bar right here will be 65. The rest of the lines here indicate how we move up or down by the standard deviation. So to get the bar to the right, I need to add 3.5. And we continue to add 3.5. So 65 plus 3.5 is 68.5, plus 3.5 is 72, plus 3.5 is 75.5. As we move to the left, we need to slowly subtract 3.5. So 65 minus 3.5 is 61.5, minus 3.5 is 58, minus 3.5 is 54.5. So now I have a little bit more information about my normal distribution that I'm going to use in just a minute to actually be able to answer some questions about this. When dealing with a normal distribution, we actually have some nice rules that help us determine what percentage of our data is within a certain range. The first piece says that there's 68% of our data within sigma of mu. So essentially we know that our mean is at the center, and if I go up and down by 1 standard deviation, that's going to hold 68% of our data. There's 95% within 2 standard deviations. So if I go up and down by 2 standard deviations, that will hold 95% of my data. And finally, there's 99.7% within 3 standard deviations of my data. So if I go up and down by 3, I'll have 99.7% of my data. So here's a diagram that kind of illustrates this a lot better. Mu is at the center. If I go up and down by 1, that holds 68% of my data. Up and down by 2 holds 95%, and up and down by 3 holds 99.7%. And this actually tells us a lot more than that using the fact that it is symmetric. So let's see if we can do a couple of examples. Back to the example we had looked at previously with US female height, we want to know what range holds 99.7% of this data. And according to the rule I said before, we need to go up and down by 3 standard deviations to hold 99.7%. So that will actually be between 54.5 and 75.5. So now we have the range that holds 99.7% of data. Another question we could ask, what percentage of women are taller than 61.5 inches? So we have our 61.5 and we're looking at all of the women taller, so all the ones to the right. And this is obviously slightly more complicated. What our rule before told us is that if I go up and down by 1 standard deviation, that'll hold 68% of my data, but that's not what I want. I actually want more than that. So we're going to use symmetry. Total, there has to be 100% of data under this curve, which means there's still 32% unaccounted for. Since it's symmetric, half of that's going to be on the left and half is going to be on the right. So there's 16% to the left and 16% to the right to get a total of 100%. So if I add up the pieces that I want, I would have 68 plus 16, which would be 84%.